Okay, a lot of people saw yesterday's video on this amp, the 68 custom deluxe reverb reissue thing, and said, well, that's great. We saw you do a bunch of stuff, but what did you do? Well, I've shown all this in other videos, but I had not done one video start to finish. So I wanted to do one full service on this amp, start to finish, and it's a three-hour job. And I think you wanted a 3-hour video of me cussing and tinning the tip and looking for my snippers and all that fun stuff that happens in real time. So I did it 10 times on playback, so 10 times speed, so you get an overview of everything that's involved. So I thought I'd do this follow-up video and just tell you what I did. And you can reference that video and the link's in the description below. The first thing I did when the amp came in is I noticed that the screws holding the output transformer in place had come a little bit loose over the years, and the flanges on the transformer were deformed. Pardon me, there'll be some coffee while this happens. This video is brought to you by coffee. And so those flanges need to be straightened. So I got some tools and kind of gave them a rough straightening, got them a lot more flat. And then because that metal is relatively thin on those flanges, I had reinforced it. So each screw, rather than just going straight into the chassis through the flange, got a stainless steel washer and a compression spring. The stainless steel washer helps distribute the load, spreads it out, helps reinforce the flange on the transformer. And the compression washer means that that thing is much less likely to ever come loose in vibration. You also saw that I tightened up these screws on the holding the choke in place. I checked that the screws on the output transformers were tight. A lot of these amps, the hardware is just never quite tight from the factory. So that's what I was doing there. Then I replaced the filter caps, and I've shown that in other videos, but showing how I remove all the old components without damaging the pads and traces on the bottom of the board, and cleaning up the flux as I go, and putting new high-quality F&T caps in place with no strain on the leads. On this series, there is a series, don't mean to say series twice. On this and the 65 reissue, they did a series filter cap for the first node, and they did it in a weird way with a small value cap in series with the well, the 47 is in series with the 220, and with the way they do the parallel resistors, it divides it up. It's not really necessary. I think they did that because they were expecting to come out, people to use solid state rectifiers in this, and the B plus would go up potentially above 500 volts, which is the rating of the 47 microfarad cap I use. Well, the loaded B plus in this amp ranges between about 400 and 420 volts, depending on how it's biased and what the output tubes are drawing. And the unloaded peaks at about 460. And that 500 volt F&T is just fine. I think even if I went to solid state rectifiers on this, it would peak about 480, worst case. So I think that was an over-enthusiastic engineer. Anyway, that's gone. So I show how to do that. Then I put a little piece of tape on the board where the filter caps are with the date, so the next tech will know, hey, these were changed in 8 of 21. Just a little note to the future. Let's see. Then I brought flipped the chassis over, and I disconnected the heater wires that were going to these quick connects on the PCB. Later in the video, you'll see that I reconnected these heater wires directly to pins 2 and 7, 2, 7 of this octal tube, just the way they did it in the 50s and 60s and 70s. It's a much more reliable setup. I leave the wires going from this octal to the board because the heater balance resistors are there, and there's not a lot of space to move them here. You also see later in the video that the primary wires to the octals was coming up in the air with a lot of excess. I moved them down closer against the chassis and removed a lot of excess. You will see at some point in the video, I don't remember the sequence, that I snipped the orange wires from the board going to the screens on the output tubes, because I was going to install a new wire bypassing the board mounted screen grid resistors. I put these new screen grid resistors on the sockets. So the 2 watts are gone off the board, 3 watts here where there's going to be better heat dissipation. On that note, of the 2 original 470 ohm 2 watt resistors that were on the board, the one that was on the right was fairly discolored. It had gotten too hot in the past. You see a little bit of that, where one of them has a blue, the stripe is still blue. The other one, that blue stripe is turned black. That had not failed yet. It was on its way. Both because 2 watts is a little bit insufficient when you don't have a longer lead length, and because if it burns the board, and I've seen it a lot, I move those over to the tube sockets. There's a 22 ohm resistor in their bias supply on the 65 and the 68, and that is just a common place for it to fail. I replace it with a 470 ohm half watt, as God and Leo intended, and the bias circuit still works perfectly. You just take out a weak link. On this series, they have the wrong negative feedback resistor, which is right here, so I snipped that. They have too large reverb mix resistor, so I changed that out over here. Let's see. I think at that point you saw me pull the board with the pots and jacks. And on that, I was changing the components in the tone stack on each channel, for both for value and for quality. And I wanted to get all the old solder off and get all the flux out before I put in the new stuff. I did this channel as if it were a super reverb, and this one to the bulk of the AB763 series, Deluxe Reverb, Twin Reverb, etc. No bright cap with an added mids pot, which takes the place of the 6.8K resistor that's here on a Deluxe Reverb. Now over on this channel, they had a 6.8K resistor, and then they had an 18K resistor in series with it, and they cut the little trace going to this pot, which makes this channel on the 68 Custom really boxy and MIDI, and I don't know, maybe it sounds cool at Guitar Center, but in comparison to actual Fenders from the 60s, it's kind of yucky. So I changed this channel to a super reverb, but I didn't change it to the left channel of the super reverb. I changed it to the reverb channel of the super reverb, even though this does not have reverb. Now, I'll talk about that in a moment. The reverb channel, the vibrato channel on a super reverb has got a mid spot. The normal channel on a super reverb does not. The normal channel has a 6.8K resistor on it for mids, same as a Deluxe Reverb. The mid spot on a vibrato channel of a AB763 super reverb, when the mids are at 5, which is where most people use them, you're actually about 2K, between 1 and 2K, depending on the tolerance of the pot, as opposed to the 6.8K. So I put in a resistor here which replicates the sound of a super reverb vibrato channel AB763 with the mids at about noon. Nothing radical, just a tiny little bit of scoop in comparison to how this channel would have been on the Deluxe Reverb. That makes this channel not sound like a Deluxe Reverb, but it sounds like a super reverb, which is super. This channel can sound like a Deluxe Reverb if the added mid spot is at about 10 o'clock, which is right about 7K, which is what the old resistor was. You can turn it below that, and you can get all the mid stuff. Like a mid spot at noon on a twin is about 9 o'clock on this pot. You can scoop it down from there, and over noon, you get into boost, which is a fun thing to have. You saw me remove the old solder from the input jacks and from the volume pots connections, because that lead-free solder that they use likes to break. It's very common. So I removed all the lead-free solder, and then I replaced that with leaded solder, 6040, which is a much better joint, much less likely to crack. The reason I had to remove the old solder first is because the leaded and the unleaded don't mix well. You end up with a gray, yucky-looking solder joint, and it doesn't have the structural strength of either. So this was just reliability. I could do every pot in the amp. The most important ones are the input jacks, because that's where the most mechanical stress is, and the volume, because that's where the most repeated turnings happen. You'll notice that aside from the added shielded wire going to the mid spot, I cut the trace from this volume and put this shielded wire going straight to pin 7 of V2. That's because in the stock form, this trace on the board goes right next to and underneath and near a lot of noisy things before it gets to the tube. And that was just a fault of the way they laid out the board. And it's easier just to do this with a shielded wire with that trace cut and that green wire removed from the board than it is to make what they did work better. I cleaned all the pots, and I cleaned all the flux off the board, and I put everything back, and I tightened the hardware. That's very important. At that point, I had this board lifted up. Over here, you saw me snipping a little blue wire here that was tying the two plates of V1B and V2B together. And what that does is that's how they mix the two channels. So on the 68 Custom, both channels have reverb and both channels have vibrato, tremolo. But that is the noisiest possible way to do it when you're mixing like that. That is why, one of the reasons why this amp has a high noise floor with nothing plugged in and the volume's off. The way they mix the reverb, the channels together for reverb and trim is the worst possible way. That plus it had not enough negative feedback, though I also fixed that. So on amps that I build, where the client wants to have vibrato and reverb on both channels, there is a good way to do it. But the layout of this board does not really allow for that method unless you have a whole bunch of janky connections up in the air and a lot of tack soldered stuff. And I don't find that reliable enough. I want this amp to work every time. I don't want any little thing to go wrong with it. So I made the decision that this channel shall not have reverb. This channel shall not have vibrato. This channel shall sound like a really good super reverb channel, though, and that's great. But there is just no reliable way. I've done it on one, and I wasn't happy with what I had to do underneath the board in terms of long-term reliability to give this channel reverb and tremolo in a quiet, reliable way. So this channel has reverb and tremolo, and it's quiet and it's reliable, and all that is great. So that's where we're at. We have a much more useful normal channel. It still says custom on this amp. We've got a much more flexible Deluxe reverb, twin reverb over here. The mid spot on the back is this modern one, not because I hate chicken heads or I hate the Fender knobs, but if you have this knob, you can't feel what number you're at if you're reaching over the amp to the back. If you have a chicken head, you can feel it. It's not as obvious. With this knob, you know exactly which o'clock position you're at. So it's a real quick thing to feel it and turn it to where you know it's going to work. If you use this amp for more than 10 minutes, you'll get a sense for the range you like and what it does. I put everything back together at that point. You saw me remove the screen grids. See, just in case I missed anything, I removed the screen grid resistors to the tube sockets. I changed out that 22 ohm to a 470 ohm. I changed, I think it was a 1.5K negative feedback resistor to 820 ohms. I added back the 220K resistor that they omitted because this is where the channels mix now, like on the AB763. I increased the reverb depth by changing their 1 meg to a 470K. I added back the output coupling cap for V2B, which they had removed. And at that point, I made sure everything was tight. I made sure the amp was biased correctly. I used a set of new tubes that I have for one of the builds I'm doing. And once I confirmed that the amp was working right, I put in the owner's electro-harmonics and biased those. It was a little variation, nothing big. And then I connected a reverb tank to it. And on the subject of reverb tanks and Fenders, traditionally, if you had a Fender AB763 circuit, it would have a Gibbs or later Accutronics 2-spring long decay tank. Long decay tank. Well, the modern reverb tanks from Belton, Accutronics, they're the same company now, and MOD And the plant that makes them from MOD also makes a version for Mojo Tone, also makes a version for Ruby, also makes a version for Tube Amp Doctor. Of the ones on the market, I find in descending order of preference, the Mojo Tone, the TAD, and the MOD to be the best sounding tanks. They're all better built than what Belton Electronics are making. Those three that I named were all made in the same factory to slightly different specs. So it's the same external casing, the same PCBs, the way things connect to the PCB, to the transducers, a little bit different. I think the transducers are a little bit different. But here's the real trick. The old tanks were 2-spring long decay. And if you get a new tank that's 2-spring long decay, the decay is way too long and it's very dark. I have found through my experiments that of the current production tanks, you want a 2-spring medium decay, which sounds the most like the old Fender long decay. And that was the cable hitting the strings. You will hear this in more detail when I do a playing video of a Deluxe Reverb using the same tank. But even here you can hear that's a medium decay tank according to the manufacturer, but it's got a long decay. That's about perfect. That is the closest I've found to the old 60s tanks, matching the decay and the timbre. A lot of the modern tanks are way too prominent in the lower mids and sound kind of boxy, and then the exaggeratedly long decay time makes that even worse. This does the whole spring thing, the sprang thing, goes up to surf levels. That won't sound as groovy and surfadelic as the standalone reverb tank because it has a dwell control, but this is a good sounding reverb tank. This one is the Mojo Tone, 2-spring medium decay. The TAD is my second choice after that. The MOD and Ruby are about tied for third. I'm not sure that there's any difference between the TAD and the Ruby. Sorry, between the Ruby and the MOD. Anyway, this has been your more detailed tour through this amp. You know, none of this is rocket science, but the sad thing is, aside from these shielded wires and the added mid spot, Fender could have done all this from the factory. You could have had this amp just as good from the factory. I guess it would have been a little more charge for them to wire the tube sockets correctly instead of having everything on the board. But it's just that they don't value the customers as much as they value their profits. And I think if more of the customers knew about the things that they do in service of profits, they may not have as many profits, and they may have to go back to focusing on the customers. So do with that information as you will.